Hello everyone, today we are going through part C of second PUC mathematics model question paper. This part C has 9 questions, you have to answer any 6. So 30th question, show that the relation R in the set of real numbers are defined as R is equal to ordered pair AB such that A less than or equal to B is reflexive and transitive but not symmetric. So here we have to prove that this given relation is ordered pair AB such that A less than or equal to B. Okay. So first of all we have to prove it is reflexive. Okay. For reflexivity, let's take an element from R. Okay. That is R is in the set of real numbers. Okay. The relation R in the set of real numbers. So let A belongs to R. So here for reflexive we have to prove A belongs to R. Right. So here what is the relation? A less than or equal to B. Right. Since A less than or equal to A less than or equal to A is correct. Right. Because equal to is there. Right. So A less than or equal to A is true. Ordered pair AA belongs to R. Right. Hence R is reflexive. Okay. Hence R is reflexive. Okay. Next. Let's take symmetry. See what is the relation? For that, let's take one element from the relation. Okay. So let AB belongs to R. Okay. Now for symmetric, we have to prove BA belongs to R. Symmetric means if AB belongs to R, then BA belongs to R. Right. So here since AB belongs to R, then what is the relation? A less than or equal to B. But B less than or equal to A is not true. Right? B less than or equal to A is not true. If A less than or equal to B, B is not less than or equal to A. Right? Therefore, here BA does not belong to R. Okay? Therefore, BA does not belong to R. So, what we got? AB belongs to R, but BA does not belong to R. Therefore, hence the relation is not symmetric. Okay. Hence R is not symmetric. Next, for transitivity, let's take two elements from the relation AB. Let AB belongs to R and BC belongs to R. What we have to prove? AC belongs to R for transitivity. Okay. Now, since AB belongs to R, A less than or equal to B. And since BC belongs to R, B less than or equal to C. Okay. See, from these two inequalities, we can combine these two inequalities. What we get? A less than or equal to B, B less than or equal to C. That implies A less than or equal to C. Right? A less than or equal to C. That means AC belongs to R. Right? That implies AC belongs to R. See, we have got if AB belongs to R and BC belongs to R, then AC belongs to R. Hence, R is transitive. Hence, R is transitive. Thus, given relation R is reflexive and transitive but not symmetric. Next question is, prove that cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. So, listen carefully how to solve such questions. See, first step is, let x is equal to cos inverse 4 by 5. Okay. And y is equal to cos inverse 12 by 30. Okay. Now x is equal to cos inverse 4 by 5. That implies cos x is equal to 4 by 5, right? And here cos y is equal to 12 by 30. Now let's find sin x and sin y. Okay. What is sin x? Sin x is square root of 1 minus cos square x. right? That is equal to square root of 1 minus cos x is 4 by 5, cos square x is 16 by 25. That is equal to 25 minus 16, 9, square root of 9 by 25, that is 3 by 5. Similarly, we will find sin y here. That is sin y is equal to square root of 1 minus cos square y, that is 1 minus cos square y. Cos y is 12 by 13, cos square y is 12 square, 144 divided by 13 square, 169. That is equal to square root of 169 minus 144, 25 divided by 169. That is equal to 5 by 30. Okay. Now we have got cos x, sin x, cos y, sin y, right? So here we have to prove cos inverse 4 by 5 plus cos inverse 12 by 13, that is x plus y, right? X plus y is equal to cos inverse 33 by 65, right? Now that is x plus y is equal to cos inverse 33 by 65. That means cos of x plus y is equal to 33 by 65. This one we have to prove, right? So cos of x plus y. What is cos x plus y? Cos of x plus y is equal to cos x cos y minus sin x sin y. Substitute these all values. That is cos x is 4 by 5 into cos y is 12 by 30 minus sin x is 3 by 5 into sin y is 5 by 30. That is equal to 4 into 12, 48 divided by 5 into 13, 65 minus 15 by 65. 48 minus 15, 33 divided by 65. See, we have got cos of x plus y is equal to 33 by 65. That implies here we have got cos of x plus y is equal to 33 divided by 65. That implies x plus y is equal to cos inverse 33 by 65. What is x and y? X is cos inverse 4 by 5 plus cos inverse 12 by 13, that is equal to cos inverse 33 by 65. Hence it is proved. Next question is, express the matrix 3, 5, 1, minus 1 as the sum of symmetric and a skew symmetric matrix. So let A is equal to given matrix 3, 5, 1, minus 1. So here we have to write given matrix as the sum of symmetric and skew symmetric matrix. And we know that let P be the symmetric matrix. P is equal to A plus A transpose divided by 2. Okay. And Q be the skew symmetric matrix, that is equal to A minus A transpose divided by 2. Okay. Now if A is equal to 3, 5, 1, minus 1, then what is A transpose? Interchange the row and columns. 3, 1, 5, minus 1. Now let's find matrix P, symmetric matrix P. See, if you add P plus Q, you will get same A. Okay. So P is equal to A plus A transpose, adding corresponding elements, 3 plus 3, 6, 5 plus 1, 6, 1 plus 5, 6, minus 1 plus minus 1, minus 2 into 1 by 2. Okay, divided by 2, that is into 1 by 2. That is equal to 6 by 2 is 3, 3, 3, minus 1. Okay, dividing all the elements by 2. Now here we have got symmetric matrix. Next, skew symmetric matrix Q, that is equal to A minus A transpose. 3 minus 3, 0, 5 minus 1, 4, 1 minus 5, minus 4, minus 1, minus minus 1, 0. Right? Divided by 2. Okay? That is equal to 0, 4 by 2, 2, minus 4 by 2, minus 2, 0. It is the skew symmetric matrix. Okay. Now here, given matrix A, that is equal to 3, 5, 1 minus 1, that is equal to 3, 3, 3 minus 1 plus 0, 2 minus 2, 0. Find dy by dx if x is equal to a into cos theta plus theta sin theta and y is equal to a into sin theta minus theta cos theta. So here given equations are in parametric form. We have to find dy by dx and we know that dy by dx is equal to dy by d theta divided by dx by d theta. Right? So let's find, we need to find dx by d theta and dy by d theta. X is equal to a cos theta plus theta sin theta. Then what is dx by d theta? Differentiated with respect to theta. That is a into constant into derivative of cos theta is minus sin theta plus here apply product rule. First function theta into derivative of sin theta cos theta plus sin theta into derivative of theta with respect to theta, that is 1. Next, dy by d theta. A into derivative of sin theta cos theta minus here apply product rule. First function, that is minus of, okay, theta into derivative of cos theta minus sin theta plus cos theta into derivative of theta, that is 1. So here a into cos theta plus theta sin theta minus cos theta. Okay, cos theta minus cos theta cancelled. Here minus sin theta plus sin theta cancelled. Now what is dy by dx? Dy by dx is equal to dy by d theta divided by dx by d theta. That is equal to dy by d theta is a into theta sin theta divided by a into theta cos theta. A cancelled, theta cancelled, so sin theta divided by cos theta, that is tan theta. Next question is, find the intervals in which the function f of x is equal to x minus 2 whole cube, x plus 4 whole cube is increasing and decreasing. Here we have to find the intervals in which the given function is increasing and decreasing. For that we need to find critical points. Okay, to find the critical points, here we have to find f dash of x and put f dash of x is equal to 0. Okay, given function f of x is equal to x minus 2 whole cube into x plus 4 whole cube, right? Find f dash of x, apply product rule. First function x minus 2 whole cube into 3 into x plus 4 whole square, right? Plus x plus 4 whole cube into 3 into x minus 2 whole square. Here 3 into x minus 2 whole square into x plus 4 whole square is common. Let's take it out. X minus 3 into x minus 2 whole square into x plus 4 whole square into here remaining x minus 2. Here remaining x plus x plus 4. Okay, that is equal to 3 into x minus 2 whole square into x plus 4 whole square into x plus x 2x minus 2 plus 2 4 plus 2. Take 2 outside, 2 is common, right? So 3 into 2 6, 6 into x minus 2 whole square into x plus 4 whole square into x plus 1. Put f dash of x is equal to 0. F dash of x is equal to 0 implies 6 into x minus 2 whole square into x plus 4 whole square into x plus 1 is equal to 0. That implies, say, if x minus 2 whole square is equal to 0 implies x minus 2 is equal to 0. That implies x is equal to 2, right? So x is equal to 2, x plus 4 whole square is equal to 0 implies x is equal to minus 4. x plus 1 is equal to 0 implies x is equal to minus 4. So here x is equal to minus 4, minus 1, 2 are critical points, and x is equal to minus 4, minus 1, 2 divide r into disjoint open intervals, that is in the real line, minus 4, minus 1, 2. Okay. So minus infinity to minus 4, minus 4 to minus 1, minus 1 to 2, 2 to infinity. These are the intervals. So here we have to check in which interval function is increasing and decreasing. Let's take. So first interval, minus infinity to minus 4. In this interval, all the values are negative, right? So when you substitute any values between minus infinity to minus 4, here see these two terms are in square, right? So whatever values are substituting here, this term will be positive always, right? Therefore, here first term is positive, second term is positive. And what about third term? See, if you substitute x is equal to minus 4, you will get minus 4 plus 1 minus 3. And here the values are less than minus 4, right? So you will get less than minus 3. Less than minus 3 means negative, right? So it is minus. So plus into plus, plus into minus, minus. Next interval, minus 4 to minus 1. See, here also all the values are between minus 4 to minus 1 are negative values. And here first term is always positive, second term is always positive. What about third term? Just a substitute. See, x is equal to minus 1. Minus 1 plus 1, 0. So here you have to substitute the values less than minus 1. Means, so here you will get less than 0. That is minus, right? So third term is also minus. So it is plus into plus, minus into minus, minus. Next interval is minus 1 to 2. Minus 1 to 2. So here the values minus between minus 1 and 2. Okay. Say first term is always positive, second term is always positive. And what about third term? See, you just substitute this x is equal to 2. What you will get? X is equal to 2, that is 3, positive. Okay. Now, if you substitute x is equal to minus 1, what you will get? 0. Minus 1 plus 1, 0. Here, the values are greater than minus 1. So, here, if you substitute any values between minus 1 and 2, here it will be greater than 0. That means positive values, right? So, it is positive. So, plus into plus is plus. So, minus. Okay, next interval is 2 to infinity. Next interval is 2 to infinity. So, in this sign of f dash of x, here first term is positive, second term is positive. What about third term? Positive, always positive, right? Because the values are between 2 to infinity are positive, right? So, here it is positive. That is plus. Okay. Now, here we have got at the interval minus infinity to minus 4, f dash of x is less than 0. At the interval minus 4 to minus 1, f dash of x is less than 0. At the interval minus 1 to 2, f dash of x greater than 0. And in the interval 2 to infinity, f dash of x greater than 0. So, here we can say f of x is increasing in the interval minus 1 to 2 union 2 to infinity. Okay. And this function f of x is decreasing in the interval minus infinity to minus 4 union minus 4 to minus 1. Find integral of x divided by x plus 1 into x plus 2 dx. Apply the method of integration by partial fractions. So, integrand can be written as x divided by x plus 1 into x plus 2, that is equal to a divided by x plus 1 plus b divided by x plus 2. Take LCM, a into x plus 2 plus b into x plus 1 divided by x plus 1 into x plus 2. Now, denominator of LHS is equal to numerator of RHS. That is, x is equal to a into x plus 2 plus b into x plus 1. Here we need to find the values of a and b. For that, put x is equal to minus 1 so that we will get the value of a. Right? Put x is equal to minus 1. So minus 1 plus 2, 1. 1 into a. That is, a is equal to minus 1. And put x is equal to minus 2 to get the value of b. Okay? X is equal to minus 2, it will be 0, right? So minus 2 is equal to b into minus 2 plus 1 minus 1 into b. That is minus 3. That implies b is equal to 2. Okay. Now substitute this a and b here. So here x divided by x plus 1 into x plus 2 can be written as minus 1 divided by x plus 1 plus 2 divided by x plus 2. Okay. So this integral x divided by x plus 1 into x plus 2 dx can be written as integral minus 1 divided by x plus 1 dx plus integral 2 divided by x plus 2 dx. Integrate it with respect to x. So here we know that it's of the form 1 by x, right? Integral of 1 by x is log x. So 1 by x plus 1 is log x plus 1. So minus log x plus 1 plus integral 2 divided by 1 by x plus 2 is log x plus 2. So 2 into log of x plus 2 plus c. That is equal to, here, see, this can be written as, it's in the form of n log x, that is log x raised to n, right? So here this can be written as log of minus log x plus 1 plus log of x plus 2 whole square plus c. Okay. Now it's of the form log x minus log y, that is log of x by y. That is log of x plus 2 whole square divided by x plus 1 plus c is the answer. If vector A, vector B and vector C are three vectors such that modulus of vector A is equal to 3, modulus of vector B is equal to 4, modulus of vector C is equal to 5 and each vector is orthogonal to sum of the other two vectors, then find modulus of vector A plus vector B plus vector C. Here it is given that each vector is orthogonal to sum of the other two vectors. And here, see, two vectors are orthogonal means two vectors are perpendicular to each other. Okay. So here each vector is orthogonal to sum of the other two vectors means each vector is perpendicular to sum of the other two vectors. And we know that if two vectors are perpendicular, then their dot product is 0. Right? That is vector A dot vector B is equal to 0. If A and B are perpendicular. Okay. So here we can write vector A dot vector B plus vector C. Vector A is orthogonal to vector B plus vector C. Therefore, their dot product is 0. Okay. And vector B dot vector A plus vector C is equal to 0 because they are perpendicular. Okay. And vector C dot vector A plus vector B is equal to 0. We need to find modulus of vector A plus vector B plus vector C. Modulus of vector A plus vector B plus vector C whole square is equal to vector A plus vector B plus vector C dot vector A plus vector B plus vector C. Simplify. Vector A dot vector A. If vector A dot vector A is nothing but modulus of vector A whole square because its angle is 0, cos 0 is 1. Okay, because what is vector A dot vector B is equal to modulus of vector A into modulus of vector B cos theta, right? If theta is equal to 0 and vector A into vector A, modulus of vector A into modulus of vector A, that is modulus of vector A square. And vector A dot vector B, vector A dot vector B plus vector A dot vector C plus vector B dot vector A plus vector B dot vector B, that is modulus of vector B square, plus vector B dot vector C, plus vector C dot vector A plus vector c dot vector b plus vector c dot vector c. That is modulus of vector c square. Okay. Now here, say this can be written as here vector a dot vector b and vector a dot vector c. So this can be written as vector a dot b plus c. Okay. So modulus of vector a square, here vector a dot vector b plus vector c, and plus modulus b square plus here vector b dot a vector b dot c. So it can be written as vector b dot vector a plus vector c. Okay. Plus here vector c dot vector a plus vector b. Here we can take c outside. Okay. So this can be written as plus vector c dot vector a plus vector b plus modulus of vector c square. That is equal to, see here, vector a dot vector b plus vector c is 0. Vector b dot vector a plus vector c is 0. And vector c dot vector a plus vector b is 0. Substitute these values. So here we will get modulus of vector a square plus modulus of vector b square plus modulus of vector c square. And remaining terms are 0. That is equal to, here these values are given. Modulus of vector a is 3. So 3 square 9 plus 4 square 16 plus 5 square 25. 25 plus 25 50. Okay. So here its square is equal to 50. We need to find the modulus of vector a plus vector b plus vector c, that is equal to square root of 50. That is 5 root 2. Find the distance between the lines. Vector r is equal to 6i plus 2j plus 2k plus lambda into I minus 2j plus 2k, and vector r is equal to minus 4i minus k plus mu into 3i minus 2j minus 2k. Okay, here we have to find the distance between given two lines, and we know that the distance between two lines, vector r is equal to vector a1 plus lambda vector b1, and vector r is equal to vector a2 plus mu vector b2 is d is equal to vector b1 cross vector b2 dot vector a2 minus vector a1 divided by modulus of vector b1 cross vector b2. Okay. So here we need to find, first of all let's find vector b1 cross vector b2. See, vector b1 is equal to, see these equations are of the form vector a1 plus lambda vector b1, right, and vector a2 plus mu vector b2. So vector b1 is I minus 2j plus 2k, and vector b2 is equal to 3i minus 2j minus 2k. Let's find vector b1 cross vector b2, that is equal to determinant I, j, k, 1 minus 2, 2, 3 minus 2 minus 2, 3 minus 2 minus 2. Expand the determinant, I into 4 plus 4 minus j into minus 2 plus 6 minus 2 plus 6 plus k into, sorry, minus 2 minus 6, okay, minus 2 minus 6 plus k into minus 2 plus 6, that is equal to 8i minus become plus, okay, minus 2 minus 6 minus 8 plus 8, 8j plus 4k. Next we will find, okay, so here we need to find vector a2 minus vector a1. Vector a2 minus vector a1. It is vector a1, it is vector a2. Vector a2 minus vector a1 is minus 4 minus 6 minus 10i. Here j component is 0. 0 minus 2 j minus 1 minus 2 that is minus 3k. Next, let's find modulus of vector b1 cross vector b2. That is equal to square root of 8 square 64 plus 8 square 64 plus 4 square 60. 128, 198, 138, 144. 144, that is 12. Okay. Next is, okay, let's find distance. Here since it is distance, the modulus is there. Okay. It's always positive. So D is equal to vector b1 cross vector b2 dot vector a2 minus vector a1. Find the dot product. Vector b1 cross vector b2 is 8i plus 8j plus 4k dot minus 10i minus 2j minus 3k divided by modulus of vector b1 cross vector b2 is 12. That is equal to, find the dot product. 8 into minus 10 minus 80 minus 16 minus 12 divided by 12. That is equal to minus 80 minus 92 98 108. So minus modulus of minus plus. Okay. So 108 divided by 12, that is equal to 3 4s, 3 3s, 3 6. Okay, 4 9s. Okay. So 9 is the answer. Distance between given two lines is 9. Bag 1 contains 4 red and 4 black balls. Bag 2 contains 2 red and 6 black balls. One bag is selected at random and a ball is drawn is found to be red. What is the probability that bag 1 is selected? Okay. So here first of all let E1 be the event. Bag 1 is selected. E2 be the event. Bag 2 is selected. And A be the event, drawn ball is red. Is red. Okay. So what we have to find? We have to find, see what is the probability that bag 1 is selected. So we have to find probability of E1 given that the drawn ball is red. That is probability of E1 given A. Okay. So what is probability of E1? 1 by 2. There are total 2 bags, right? So probability of E2 1 by 2. And probability of A given E1, that is drawn ball is red and it is given that first bag 1 is selected. Okay. So in bag 1 there are 4 red balls and total 8 balls. So therefore probability of A given E1 is 4 by 8 and probability of A given E2 is 2 divided by 8. What we have to find? We have to find probability of E1 given that drawn ball is red. That is probability of E1 given A. That is equal to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Substitute probability of E1 1 by 2 into 4 by 8 divided by 1 by 2 into 4 by 8 plus 1 by 2 into 2 by 8. That is equal to 4 by 16 divided by here 4 by 16 plus 4 by 2 by 16, that is equal to 16 cancelled. So 4 divided by 6 that is 2 by 3. The required probability is 2 by 3.